I'm a hydrologist with DNR. Thank you for having me here today. And, I just want to thank you guys for everything you do protecting our natural resources. That's the first time I heard about the pipeline, so I don't know how that one flew under the radar, but look into it. Okay, I'm going to talk about three different things today. A groundwater flow model that's being developed for the county, and that's being done by the USGS. DNR is one of their cooperators in that project. That's funded through, I think the Aiken Water Utilities is actually funding that project. That started in October this past year. It's a 3-year project, so we're just getting started with it. Now I want to talk about, you might have heard about the statewide surface water quantity models that are being developed for each of the 8 major river basins in the state. We'll talk about that. And then my colleague Scott Harder, who's down from Clemson, I appreciate him coming down from Clemson to talk about the agricultural surface water use that you may have heard of. It's been in the newspaper a lot. I don't know if this, I don't have a remote, so I'm just going to go through this. I wasn't sure what your backgrounds were, so I just kind of wanted to give you just a brief overview of the hydrology in South Carolina. The Piedmont region covers about 1/3 of the state. It's underlain by very hard, dense, practically impermeable rocks. Very hard to get groundwater out of the Piedmont. It's kind of a hit and miss proposition. We get calls, and people want to know where they should put their well. And it really is kind of a crapshoot, you know. The wells just have to intersect some of these fractures that are in these rocks, and we just don't have good maps of where these fracture zones are. And if anybody does figure out how to find groundwater in the Piedmont, the first thing you do is call me. And we'll get rich together. Okay, and then the coastal plain covers about 2/3 of the state. You know, Aiken County is right up against the fall line, which is really the contact or the boundary between the Piedmont and the coastal plain. So the coastal plain is underlain by really loose, unconsolidated sediments, sand, clay, and some limestone when you get down towards the coast. So the groundwater does not flow in underground rivers. It flows through sand grains. So just these layers of sand that are underground that form our aquifers. Now these layers of sand can be mapped across the coastal plain, and they get up to 200 feet thick. So you can imagine the volume of water that we have under the ground. So, okay, so I'm going to talk about Aiken County. So if we drew kind of a cross-section going from Greenville through Aiken and down to Hilton Head, Greenville's up in Piedmont, so if you drill a well there, you're going to be in the hard rock. Aiken's kind of, like I said, it's right on the edge of the boundary between where the Piedmont and the coastal plain are, called the fall line. If you drill a well in Aiken, the town of the city of Aiken, you'll have to go down about 500 feet till you hit the bedrock. So you have about 500 feet of these loose sediments, coastal plain sediments, before you hit the bedrock. So these sediments thicken. You see, it's like a wedge of sediments that thicken as you get down towards the coast. By the time you get to Hilton Head, you have to drill 3,800 feet till you hit bedrock. So the green layers are these clay layers. Clay layers are, for the most part, impermeable, and they hydraulically separate the aquifers from each other. They thicken, but by the time you get up to Aiken, they're relatively thin. So these yellow layers here are the aquifers, and the green layers are these clay layers that kind of hydraulically isolate the aquifers from each other. And if you have any questions while I'm talking, please feel free to ask. So now let's kind of zoom in on Aiken County. Like I said, if you drill the well in the town of Aiken, city of Aiken, you have to go down about 500 feet before you hit the Piedmont. The county line, the Aiken-Barnwell County line, you have to drill about 800 to 900 feet. So the coastal plain's getting thicker, the aquifers are getting thicker. And like I said, by the time you get, even in Allendale County, you have to drill about 1,500 feet to hit the Piedmont rocks. There are 4 major aquifers. The McQueen Branch Aquifer, this is a nomenclature that we adopted from the Savannah River site. You guys might know this as the Middendorf Aquifer. I don't know if you guys are familiar with the nomenclature. the Crouch Branch Aquifer, also known as the Black Creek, the Gordon Aquifer, and the upper three runs. The two most productive aquifers by far are the Queen Branch and the Crouch Branch, and the Queen Branch is actually more productive than the Crouch Branch. So these are the two aquifers that are used in this area. By the city of Aiken, SRS uses these aquifers. A lot of the other smaller towns use these aquifers. The Gordon is used occasionally for domestic supply, but very little water in the upper three runs. It's the superficial aquifers, so it's not used that often. So these are the four aquifers that will be included in this groundwater model. And you'll notice these clay layers that separate the aquifers are really getting thin as you go towards the northwest, towards the fall line. They get discontinuous. They're a little sandier. They're not really dense clay. So the aquifers are really not hydraulically isolated from each other in this area. Everything's kind of more or less connected, hydraulically connected. So if you were to pump this aquifer, you would probably see water levels decline in this aquifer and this aquifer. Everything's more or less connected, for the most part. It's important.
I've got a question.
Yes, sir.
On that model, where are most of our wells? Our wells from our home are coming from the upper three rows?
No. Usually we don't use this aquifer because it's the shallow aquifer. It's really
shallow. How?
Okay, yeah. Let me give you an idea. Here, maybe the upper 100 feet. Is the upper three runs aquifer. Then the Gordon down to about 200 feet, and then from 200 to about 500 feet, you're looking at the Crouch Branch and the Queen Branch. So I'm not sure. I would think that most of the domestic wells are probably either in the Gordon aquifer, maybe 150 feet, or in the Crouch Branch aquifer, maybe 250 feet, thereabouts. A lot of the big production wells are definitely in the Crouch Branch and in the Queen Branch. Like I said, the most productive aquifer is this lower one, is the Queen Branch aquifer.
The recharge, maybe you're going to go, is the recharge area up at the fall line?
Yeah, it's really right here.
Right here, Nathan?
When it rains, it seeps down.
Okay.
Like I said, these confining units are very thin, discontinuous, so water just kind of leaks. Now, a lot of the water will just kind of discharge into the surrounding streams. So not all the rainwater gets down into these deeper aquifers. But we are in the recharge area all throughout, I would say, for most of Aiken County, Okay, so for the model, for this groundwater flow model that we're developing, we use these existing wells that we have. These are the green dots here. And this purple line here is actually the fall line. And we've extended the model, and the rest of this is actually just the study area. So it includes all of Aiken County. We're also including the northern parts of Barnwell County, the northwestern part of, this is Orangeburg County. I think Walter's Farm is right about here, if I'm not mistaken. It's on the county line. So I think this is where they have a lot of their wells. We've also extended the study area into the western regions of Lexington County to pick up the Gilbert Summit wells in that area. But these wells, I'd say half of them are monitoring wells that are either owned by Savannah Riverside or DNR. The other wells are either industrial wells, public supply wells, irrigation wells that we're using to define the framework of this model. The blue wells that you see up here are shallow wells that were drilled by the Geological Survey. They're only probably less than 100 feet, all of these. These get down to about 800, 900 feet. The ones in Aiken, maybe about 500 feet. What you see here is actually an area where the coastal plain sediments have been eroded by the stream. So there's actually the hard rocks, the Piedmont rocks are exposed on the stream bed. So if you were to walk the stream bed here, you'd be walking on the Piedmont rocks themselves. That's what these things are here. Okay.
Let me ask you a question. Shaw's Creek, right at Interstate 20, we got 1 million gallons per day spraying.
The shallow springs?
Is that unusual? Behooves me a million gallons per day.
That's tremendous. I think the city was using that at one time.
Oh yeah, it's been going on for 100 years.
Yeah. That's very unusual to have that flow coming from a spring, you know. Aiken was kind of unusual because I think it's the only city that actually uses groundwater, surface water from Shaw, right, Shaw Creek.
Yeah.
And then it has a spring too.
Well, yeah.
Yeah, so most of the water comes from, I think, from the ground. I think maybe 80% of the water is from.
Yeah, 80%, yeah, well, 30%, I think, is surface water.
Yeah, okay. So I think Aiken is actually maybe up to 8 million gallons per day in the city of Aiken. Maybe 6 or 7 of that comes from wells, the other from the spring and surface water. And, you know, and if you look at a chart showing their, you know, over time, back from, I guess, from 1980 to present, their water demands have increased pretty dramatically. Okay, all right. So from each of these wells, then, what we're trying to do is build what we call a hydrogeologic framework, and that's just the 3D spatial representation of the aquifers and defining units. Notice how deep are the aquifers, how well connected are they? So we're using all those wells I showed you on the previous slides to build this framework. Now what we have are cores, which are continuous samples. I would say maybe a third of the wells that we are using have these core samples. Very important to us because we could identify exactly where the aquifers are, at the top of the aquifer, the bottom of the aquifer, and the confining units, exactly where they are. We also use geophysical logs. All the wells have geophysical logs, and these are very valuable to us. After a well is drilled, we run what are called electric logs, geophysical logs down the well, and they indicate where the water-bearing zones are. So when the log kicks to the right, like it does here, that's sand. When it kicks to the left there, that's clay. Sand, kind of a mixture here, clay, sand. So they're very useful for identifying the water-bearing zones and these clay layers. That helps us to map these aquifers and confining units across the county. Sometimes they have fossil data. These are microfossils that we find in the cores, and paleontologists are able to age date them, determine how old those layers are, those clay layers or the sand layers, and that helps us correlate the aquifers from one well to the next if you know the ages of the layers. And then we have geologic maps that were produced by the South Carolina Geological Survey, very useful to us. So we put all this information together, and these are the wells. We still don't have those boreholes in the model yet, the ones that we drilled on the survey. But these are the wells, and they're color-coded by the aquifer. This blue here is, you know, at each well we go ahead and delineate the 4 different aquifers and the defining units. And that's what we've done here for each one of these wells. So the blue is the McQueen branch, the red here at the bottom is the Piedmont rocks, and the blue is the McQueen branch, the yellow is the Crouch branch, the red is the Borden, and then the green is that upper 3 Runs aquifer. So then we plug all this information into the model, and it kind of interpolates between all those wells. So these are the aquifers in the county. Again, the red here is the Piedmont. The blue is the McQueen branch, that's the deep aquifer, Crouch branch, Gordon, and then the upper 3 Runs. Any questions on that? So you see what it did there? It just kind of connected the dots, really, to form these solids, each solid representing an aquifer. What's nice about this, now when you have this, if you're going to drill, let's say right there, if you type in, you know, the lat long, you type the lat long into the program, it'll tell you the depth to each one of these layers.
And that basically was, that knowledge was acquired through the electrical resistance in your test wells?
Yeah, and the core data.
Mm-hmm.
You know, we use the geophysical logs, the core data, all this information really to delineate the aquifers. And these aquifers were delineated at SRS, and I have them even delineated across the whole coastal plain. Not at this detail, you know, but so we kind of extend the mapping that was done at SRS up into, you know, Aiken County, okay, you know, with more detail. So.
So mostly the aquifers also have holes in them, apparently.
What's that?
You see the red right there in the middle of all the green, kind of,
Yeah, but this is the Gordon aquifer. This is the Gordon.
so there is no 3 runs aquifer.
There's no upper 3 runs, right? It's been eroded away. Yeah. And then you get to the stream valleys, and everything's been eroded away except this McQueen branch aquifer. And this is just the very preliminary version. We're going to be adding more wells to get a more detailed picture of it. Okay, so we take that framework, we add in information like all the wells that are being used in the state, the water use that's being used in the county, excuse me. Through pumping tests and other analyses, we determine what the hydraulic properties are of each one of those aquifers. And eventually we'll build this groundwater flow model. It's a mathematical computer model. It's not going to be a physical model. And what we'll be able to do with that model is determine the groundwater availability, flow rates, flow directions. We'll be able to evaluate the impacts that current and future pumping rates have on groundwater and surface water resources of the county and on other groundwater users. And we'll be able to evaluate future withdrawal scenarios to maximize groundwater production and minimize undesirable effects of pumping. So what you could do with this model is, let's say the city of Aiken determines that its water demands, its future water demands will increase by 80%. You could plug that into the model and you could see what the groundwater level declines would be if they did increase their yields by 80%. You could see how that's going to affect base flow in some of the surrounding streams. You could see if a cone of depression starts to develop. So you can see, you can start using it to predict what's going to happen, what the effects of future pumping would have on the system. I did want to mention this, most of our streams, we call them gaining streams, so they may be fed by groundwater. Groundwater discharges to the stream, we call this base flow. I always tell people if we had a plug here, we're able to pull the plug and drain all the water out of the ground. Most of our streams would probably go dry for half the year, probably. So groundwater is an important component to keeping our rivers and streams flowing year round. And I think what this model is going to be able to do, I say I think because we got to get the details right. But let me show you this map. This is a potentiometric map of the McQueen Branch aquifer. The McQueen Branch is the deep aquifer. What we do is we go out to these wells. All these wells are producing from the McQueen Branch aquifer. And we go out in November, usually we measure the water levels, and then we plot those up. And we reference them to sea level. So these are the actual water level elevations in each well. If you draw a line perpendicular to these green lines, that indicates the groundwater flow direction. Okay, you with me? So I drew these arrows in here to show which way groundwater is moving. And this is from the deep aquifer now. These wells are 500 feet deep. These are 800, 900 feet deep. Water is moving towards the Savannah River. What does that mean? That means that that water is discharging into the Savannah. So if you pump here, theoretically, if you pump enough, you're going to reduce the base flow of the Savannah. Now you have to pump a lot of water. But do you guys understand that?
I think so. That has pretty serious implications for the Edisto.
That's what I'm getting at.
Okay.
Okay.
Yeah. So
Now,
if you pull a lot of water out of the ground, it will definitely have an effect on this.
Yeah, but it might be very small. And we're thinking, we did a similar model in Chesterfield County, and we're able to quantify the amount that the decrease in the base flow due to pumping. But with the model too, you could add pumping. Let's say in the future we're going to pump 10 times as much. You can put that into the model and see how it affects the base flow. Now the Savannah does downcut very deep. The elevation of the stream bed right about here is maybe 125 feet above sea level. So the stream bed, the river is really down cut or incised into these aquifers, which is causing them to drain. It's causing the groundwater to drain. The South Fork, it hasn't down cut that much, you know. So the elevation, I think, is maybe 250 feet above sea level, so it doesn't down cut into those aquifers as deeply as a savanna. So we might not see as dramatic an effect as this. But anyway, that's one thing we're hoping that the model could answer. How is pumping affecting base flow, you know, of the Edisville River?
So can you say again which aquifer the South Fork cuts down into? It doesn't get down to the...
No, I think it probably cuts down into the Gordon. That's that
Okay.
second aquifer.
Okay.
I'd have to do a more detailed analysis of that. Okay, so that's an important, I think, product of the model. Okay, I want to switch gears here to the surface water quantity models. Okay, so now we're back on surface water, rivers and lakes. The first water plan came out in '98, and wouldn't you know, we go into a major drought in '98. We call it the drought record in South Carolina. It lasted, I don't know if you guys remember, I was getting calls every day, but it lasted from like 1998 to probably the fall of 2002, so it lasted about 4.5 years. Serious drought, you know. Stream flows were at historic lows, lake levels were dropping. I think we had storage for maybe 90 more days in some of the Savannah lakes. Wells were going dry, and people had to lower their pumps. So we said, okay, let's, you know, in light of what we learned from the drought, let's go ahead and update the water plan. One of the recommendations was for the development of regional water plans for each of the major river basins in the state. These are the major river basins. Okay. So for each one of these, we'll be developing a water plan, a regional water plan. And that's what we'll be using these surface water models as a tool during the water planning process, and I'll explain how that works. But each one will have a water plan. And what we're trying to do, we're trying to determine how much water we have, you know, how much we'll need in the future, and then how are we going to meet those future demands? What strategies will we come up with in 50 years from now? So a water plan and a model, and a surface water model will be developed for each one of these basins. And we're starting with the Saluda, actually. The Saluda is our pilot study area. This project started, I guess, in August of 2014, last August. You know, we went through an RFP, we put out an RFP, a request for proposals, and we got 6 proposals back from consulting firms, environmental consulting firms. CDM Smith had the best technical, one of the better technical proposals, and that their price was right. So they were awarded the contract to develop these surface water models for us, with oversight from DNR and DHEC. And so we're collaborating on this project. And then Clemson is facilitating the stakeholder meetings. And I'll talk more about the stakeholder meetings. There's one coming up for the other stuff. Okay, so before we start developing these regional water plans for each one of those basins, we want to develop these surface water models. The models will be used to determine surface water availability. How much water has been in the basin in the last 80 years? That's what we want to know. And we're most interested in the droughts. Serious drought, I think there's a drought in the 30s, the 50s, the 80s, because we want to look at the worst case scenario, and that's the drought. Those years when we had drought. So was there enough water in the Saluda Basin back in the 50s when we had that 3-year drought to meet our current demands? Because we're going to have that same level of drought again. Was there enough water back in the 50s flowing through the Saluda Basin to meet our future demands? Or are we going to have shortages in the future? That's what this model is trying to, those are some of the questions that this model is trying to answer. Be able to predict, using the models, where and when water shortages would occur. We could test different water management strategies to try, if we find out there will be a shortage in 30 years, we could test different management strategies, release less water from the lakes, build additional reservoirs, or reduce demands through conservation measures. You know. We're also hoping that There's always water disputes, you know, so we're hoping that the model is more of like an objective thing where we could resolve some of these water disputes that may arise. We can evaluate the impacts that interbasin transfers have and withdrawal permits. DHEC is using this to evaluate their permit applications for surface water withdrawals. And then to support the development of drought management plans. So like I said, CDM Smith was awarded the contract. They started in last August 2014. We're trying to get all these models done in 2 years. Right, the Saluda, like I said, is the pilot basin. We're almost finished with the Saluda model. We think it will be done in June, next month. Okay, we've had one stakeholder meeting so far. Clemson is facilitating the stakeholder meetings. We plan on having 2 stakeholder meetings per basin. Like I said, we just held one several weeks ago for the Saluda. We'll be holding one. The next basin that we do is going to be the Edisto, by the way. We're going from Saluda, the next one will be the Edisto. So it looks like our first stakeholder meeting for the Edisto will be the week of June 15th. We haven't set an exact date yet, but you guys will definitely be notified. Are we looking for a facility? If you guys...
How many people?
150. If you guys think of anything, you know. We're thinking, you know, the basin, we can hold it in, we want to hold it in the Edisto basin. But anyway, if you guys think of somewhere, you know. So they're maintaining a website called SC Water Model. Is that right? Water Model?
scwatermodels.com.
scwatermodels.com. If you Google that, it'll take you to their website. DNR also is maintaining websites. The hydrology webpage at DNR, and it has all the technical documents there. It has progress reports. Every month we put out a progress report. It has maps and everything else, so we encourage you to check out those 2 websites.
I think the Clemson site is still a work in progress.
It is, yes. So we're using this model called the Simplified Water Allocation Model, SLAM for short. It's difficult to explain what this model does. What it does is it's a mathematical model, but it's simple math, my kind of math. It's addition and subtraction. So what it's doing is just seeing how much water is in the river. If there's a withdrawal, it takes that water out and routes the rest of it downstream. But it's looking at the historic stream flows, the stream flows that we had over the last 80, 90 years. So it's routing those stream flows down the river to see if we have enough water. If there's too many withdrawals, then there's not going to be enough water downstream for the next guy. Let me see if maybe I can explain it a little better as we go on. There are a lot of steps involved in developing one of these models. Data collection. We have to compile all the hydrologic and water use data for each basin. This means all the stream flow data from the USGS stream gauges have to be compiled. Going back to the earliest stream gauge, the earliest US stream gauge in the basin. So for the Saluda, we have a gauge that goes back to 1925.
Wow.
So we have to collect, what we want to do is collect all the information going back to 1985, all the water use data. If there was a withdrawal, we want to know about all the withdrawals, all the discharges that have taken place back to 1925. Because what we want to do is we want to develop what's called an unimpaired flow. That's a natural flow. We want to take, the USGS stream gauges really have been altered by humans, by dams. So what you see on the USGS stream gauge is really not the natural flow. If there was a withdrawal, for example, upstream of that gauge, that gauge would show a lower flow than really naturally is there. So for what we want to do is develop these natural flows by wherever we see a withdrawal, we want to add that back into the river. Wherever we see a discharge, we want to remove that from the river. If somebody's discharging water into the river, we want to take that back out. If there's a dam, we want to account for the effects that the dam had on the flow of the river. So we're trying to get at the natural flows of the river before there are any humans. any human, diversions or dams. That's a huge job. Then we want to go back, and the USGS stream gauges, sometimes we only have a 10-year record or a 20-year record. We want to extend those records using statistical techniques all the way back to 1925, so we have a complete record. For each one we have 34 stream gauges in the Saluda. And we want to extend it forward to 2013. So we want to have a complete stream flow record for each one of the gauges. It's tricky because you have to do regression analysis. We use statistical techniques to do that. It's not the real thing, but it gives you an idea, a feeling of what the flows were at each one of those gauges.
Did you say extend it forward to 2013?
Yeah. So let's say there was a gauge that only had data from, let's say, 1970 to 1990.
I got you.
We would extend that backwards to 1925, so we have a complete record, and forward to 2013.
Okay.
Okay. Then we develop a basin schematic showing all the users in the basin, all the reservoirs. We do a calibration where we try to, we compare the simulated stream flows and the simulated reservoir levels with the actual stream flows and actual water levels to see if the model is working properly. And then we do what's called a baseline model run. So what we've been doing over the last several months is compiling all the information that we need for the model. So this is the Saluda Basin, and these are all the tributaries that will be simulated with the model. We're not including all the tribs, because we decided just to simulate or model those tribs that have some kind of water management on it, either a withdrawal or a discharge, and that's what. So we'll be simulating all the lakes. Lakes is like Murray, Greenwood, Table Rock is up here. So we simulated. I think there are 7 or 8 lakes or so, and these tribs. So we put all that information together. Then we have to, these are all the surface water users, the current surface water users in the basin. Golf courses, industrial users, mining, thermal electric, drinking water, hydroelectric. Put all that information together. All this goes into the model. These are all the dischargers. Right?
Big discharge.
The big discharges. We have a threshold of 3 million per month. If they're less than 3 million gallons per month, we really don't include them in the model. These are the bigger ones. All that data comes together, and there's more data actually, but I'm going to do it. And we put that into the model, and this is what the schematic model looks like. Each one of these objects here, this is a golf course withdrawal. This is one of the tribs that we'll be modeling. This is a USGS stream gauge. We account for interbasin transfers in and out of the basin. These are the lakes that will be simulated. Okay. And to me, this is really the question that we're trying to answer. And in models we do a lot, but I want to know, do we have enough water in our basins to meet both the in-stream for the fish and wildlife, and recreation, and water quality, and the off-stream demands, off-stream being for industry, irrigation. So do we have enough water in our basins to meet these demands 50 years into the future? And that's what we're hoping this model will do. Okay? Another important aspect of this whole water planning thing is developing these surface water models, but also doing water demand forecasting for the next 50 years. We have to forecast or predict how much water each one of these municipalities will need over the next 50 years in 5 or 10 year intervals. How much is irrigation water use going to increase over the next 50 years? Industrial water use, thermoelectric water use. So we have to do what's called water demand forecasts. They get plugged into the model. Okay, well this is the schedule. We started last August. Like I said, we're starting with the Saluda, then we're going to the Edisto and the Broad, PD, Catawba, Santee, Savannah, Sackahatchee. Hopefully getting them all done within 2 years. And CDM Smith has been around target with their deadlines, and they met every deadline so far. Okay, just a quick thing on the water planning part of this. There are really 5 steps that we see for updating the state water plan. We're doing the surface water models to tell us how much water is in our surface water bodies, lakes and rivers. Then we're developing a statewide groundwater model. It won't be as detailed as the Aiken County model, but we're doing one for the entire state with the USGS to tell us how much groundwater we have. Then we're doing the, what I just explained, these water demand forecasts over a 50-year planning period. Water demand forecasts will be made for agriculture, energy, industry, and public supply at 5 to 10-year intervals over a 50-year plan. We could plug those into the model, our 50-year forecast, to see if we have enough water. To see if there was enough water in that basin to meet those demands. If there was enough water over the past 80 years to meet those future demands. You understand? Yeah. So once we have the models developed and these water demand forecasts, then we start planning. And the way we envision it is that the stakeholders will do the planning. And we'll have broad representation, all the stakeholder interests to be represented. And I think the state will, we haven't settled on this, but I think the state will just provide oversight. But the stakeholders will have a big hand in developing these plans. We'll run the models for the stakeholders. If they want to see a certain what-if scenario, we could run that, given the results. Some of the things that will be in the regional plans, analysis to determine if any water deficits will occur in the future, and then the management strategies to meet these future demands. Okay, and then we have, so at that point we have 8 regional water plans, and those will get summarized into the state water plan. And what we're thinking, really, the state water plan should be kind of a policy document. So what we're going to ask of the regional plans is for them to recommend new policies or new programs or changes to them. So if they don't like the Surface Water Withdrawal Act for some reason, and if all 8 of them say we got to change the Surface Water Withdrawal Act, then that will be one of the recommendations that's made in the state water plan. You know, if 6 out of the 8 basins say they need more groundwater data, that will be a recommendation in the state water plan. We'll recommend that we get more monitoring wells. You know, get the idea. Questions? I know that's a lot.
And if I can make one comment about getting to that point where we've got the plan is, and we've talked about this before, South Carolina, we've been a little behind on getting this data compared to Georgia and North Carolina. And in the event we end up in court over water issues, we need the science and this plan to show the courts, we know what we're doing here. We know what we've got and it's ours. And, you know, so we're ready to go to court too.
These interstate issues are becoming very serious. You know.
And y'all all know, I mean, we have enough growth pressure in South Carolina, but think about Charlotte and Atlanta and Augusta.
Well, we're downstream, you know.
Yeah.
So that's what I was gonna ask is, in your modeling for Savannah, are you going over to Augusta and modeling them too?
Yeah, all that, we'll be using information from Georgia, because we share that river. You know, so we have to know how much water they're withdrawing. So we have to get all their water use information, which we'll do. Very talk to them. They'll provide that. You know, they have stream flow records and how they operate reservoirs and things like that. So we are working with the Georgia EPD on that, and with the North Carolina DENR, Department of Environmental and Natural Resources up there.
So with the Savannah River, that's second to the last.
Yes.
Okay,
Was it? Yeah, I think
it was.
Yeah, it is.
I thought that was interesting as being one of the rivers that you would.
No, that's right.
But y'all will have the same opportunity when we
Okay.
get to that stakeholder meeting.
That's what I was wondering, if we'd
Because
be involved with that too.
Yes.
Yeah, yes.
Good,
Yeah,
okay.
that's right. That's right.
When you're talking about changes in forecasting the water,
Demands.
the demands and the usage of the, the foreseeable problems that we may have, over what period of time would you look? You know, you think of the weather, it's a pretty quick thing, but with the groundwater, how how soon can you see that, we've got a problem, we're foreseeing that there may be a problem in the next few years? Do you see what I'm asking?
Well, once we know how much water we're gonna need in the future, we plug that right into the model, it'll tell us.
Okay,
Hey, the
but-
water levels in this aquifer are gonna go down 50 feet if you try to pull that much water out, So you should look for an alternative source, either a surface water source, or you better cut back on your demands,
okay.
or you might go to a different aquifer,
So, going backwards from that, will this model be used to say in Aiken County, you're using this much water, you're using more water from the ground than was previously used, we foresee there being problems?
Mhm.
And in my asking that, how will they know if some of the smaller, I guess, if we have a lot more people moving in a lot more wells, and you start pulling more groundwater, how are they
You
going
mean
to
the
know?
impact from all these other wells?
Yes.
Is that what you're saying?
Yes, I'm just trying to get an idea of how are they
Yeah.
going to know.
Yeah. Well,
Do
we
you see
have,
what I'm trying to ask?
well, we have
Like
information.
development,
Like development.
if you put 1,000 personal
Yeah,
wells.
yeah, well, we have that information.
Okay.
Anybody who uses, even groundwater, uses more than 3 million gallons per month is required to report that to the well.
Okay, well, there's a lot of people that use
Oh,
less
I
than
know,
that.
I know.
And that's what I'm just
We
like.
make estimates on those
Okay.
values. They're rough estimates, domestic
Okay.
use.
And that'll be incorporated into
Yes,
the
and all
model
that gets
too.
into the model, so it's a
Okay.
total use, not just the city of Aiken or,
Okay.
or North Augusta, it's everybody, it's a cumulative amount.
I had a couple of questions.
Go ahead.
I'll just ask them all and then you can answer. Are y'all doing, bound point and point studies with that? Are y'all looking at TDLs? And are y'all using the 2011 ag census data? Or y'all got a more current ag census data?
All right, as far as water quality, that's not, being incorporated into this model. This is a water quantity model. But remember, the amount of water in the river really, affects how much pollution you kind of, or discharge into the river. So it's important to know what our flows are. But it's not, we're not looking at non-point sources or point sources. No, we're not doing that. We are using the 2011 ag census. Yeah.
And then, also was wondering, how come the Army Corps, when you were talking about dams and, man-made structures, how come there, most dams are after 85, we started doing the permitting process. Are y'all looking at their permitting data, or are y'all just using GIS to locate man-made structures?
No, I think we know where all the dams are, if that's your question, in the state, the larger dams for sure. And I think that's a program that's administered by DHEC, a Dam Safety Program. So as far as I know, they have information on every dam in the state.
I think there is, if I'm not mistaken, in their dam height requirements, 25 feet.
25 feet,
So
yeah.
anything under 25 feet.
Yeah, make it under
You would
the
go Army Corps, correct?
Oh, I'm not sure if it is.
Yeah,
Well,
what happens is you build a pond and get exempt from having land disturbance permit, and you go through DHEC and get exemption from their dams program. And by getting exemption from their dams program, they know that you put the dam
Oh, I
in
see.
the
I see.
pond.
So they know it's there.
I was just wondering if you were just using aerial GIS.
Oh, no,
Well, we're only considering reservoirs that are gonna have a significant impact on the basin's water, so a lot of your smaller lakes and ponds aren't gonna have an influence. So,
Even some of the dams, like on the Broad, are kind of running the river. They really don't store that much water behind the dam. And,
you don't have a lot of storage.
yeah, so they don't have a lot of
Down
impact
again.
on the downstream flow.
Do reservoirs have a significant impact in terms of evaporation?
Oh, absolutely.
Like,
Yeah.
can you give?
We consider that too, if that, when we're developing these natural flows, trying to get at the natural flows of the river, if that dam wasn't there, right, there'd be more water in that river because there's a pretty significant amount that's being evaporated, so we account for that actually. But it could get really high. I forget what the numbers are.
In agriculture, you basically don't have to have a permit whatever withdrawal from the river, then you've got a certain level, but then when you get thousands of folks doing the same thing, it does make it into a big quantity.
Absolutely, yeah. Yep.
Do you have any idea how long it takes to put a gallon of water back in the aquifer?
No,
The reason I'm asking that question
it's a good question.
is obviously there's a farm around here who's got a lot of attention. And they've got ground wells, and they got surface.
Mhm.
And it seems like everything I hear, all the bickering is they're pulling water out of the river. From what you just said, you got to have groundwater to have a river to begin with. So if you're gonna pull water, it would make more sense that it's easier to refresh the water in the river than it is in the ground. Is that incorrect?
It is, that's correct.
Okay.
Groundwater moves very slow,
Right.
on the order of maybe a couple hundred feet a year.
So if
So it takes a longer time to recharge that aquifer, but there are tremendous volumes of water under the ground.
Sure.
And they do recharge. The
right, but if a farmer's gonna irrigate,
Mhm.
isn't it gonna be better to irrigate out of a stream than it is the
Well,
ground?
I'll tell you this, what I would like to see,
Scientifically.
Yeah, I mean,
it depends on the river, of course, and everything, but,
I'm talking about
during low flows, during the summer months, why not use both surface water and groundwater conjunctively? During the summer months, pull from the ground, from the well, and during the late summer, and then maybe during spring, you could pull from the river, you know?
When do we get to a point like these other areas in California, the ground's actually going down 6 inches a year?
That's a good question. It's called subsidence. Yeah. And it's a big concern of mine, and I've been talking to the state geologists about that. Especially in coastal areas where water levels, believe it or not, from pumping have dropped 300 feet. 300 feet. And in other areas of the country, when that happens, the ground sinks. It's called subsidence. It's gradual. It's not like a sinkhole where there's a sudden collapse. But that's happening.
But some
It
areas,
could be happening, and we don't monitor. That's the thing. We don't have any monitors in place. It's not an easy thing
but
to
it's
monitor.
not half inch, it was sizable.
Yeah. It could be several feet. It could be, actually, I think in the Central Valley in California, it was like, I think it was 30 feet in some places, you know? I had a guy standing next to the telephone pole, and there was a mark like 20 feet above his head. That's where land surface used to be. It could be happening at Mount Pleasant, where we've had these big withdrawals that cause some serious drawdowns, you know, groundwater level drawdowns. But we don't have any evidence of it because we're just not looking for it. We don't have any monitoring systems in place.
Well, if you're only 12 inches above sea level to start off with,
That's right.
you probably hear that.
You know, with sea level rise and subsidence, you know, you know. But anyway, I'm gonna turn it over to Scott, unless there are any other questions.
Scott's coming up. Let me say that I will, when the Edisto stakeholder meeting is announced, date, time, and location, I'm going to make sure all the district chairs in the watershed, and keep in mind, this watershed goes all the way to Charleston. There's a really good map on our website of the watershed, and it shows the county lines too. So I use this map to go by, to invite the district chairs, and then ask the district offices to get this to anybody else who's interested. This is not by invitation only. This is a public meeting open to anyone who has interest in this, who should be everyone.
So that stakeholder meeting could be anywhere from here down to Charleston? Are they gonna have several in the different areas?
Well, no, there'll be one meeting.
Okay, that's what I
My
was hearing,
guess
but-
would be, and Joe, we haven't talked about this, so tell me to shut up if you want me to. But I mean, Orangeburg's about the middle of the watershed,
That's
so
that's what we were thinking.
the most logical
Yeah,
place.
centrally located in the basin.
Ready? Okay. Well, thanks for having me. I'm here to talk about some historical water use and some information on the agricultural registrations. I presented similar information at the Farm Bureau last November. I don't know if anybody besides Mark was there, but it was basically going over some of the same material. And then some of these slides were distributed out, and I think you may have seen a copy of them in different publications in the newspaper, maybe referenced a time or two. That's the DNR report that some of you may have heard about it, but it's really just a presentation, so I'm not sure how it got turned into a report. It did. Anyway, mostly the data I'm dealing with and talking about is going to be the water use database that DHEC maintains, and they collect the data. Just a little history on reporting requirements, and Jeff, let me jump in, just feel free. Prior to 2000, 2001, most water use reporting was voluntary, is my understanding. In about 2000, 2001, reporting became mandatory for any user withdrawing more than 3 million gallons per month in any 1 month. All right. So we only have what I would call reliable and consistent data after 2001 or so. So I basically start, anytime I analyze water use data in the state, I typically start at 2002. Okay. Another thing I'll go ahead and mention is that a couple years ago when the surface water bill got passed, some of your smaller irrigators and golf courses were no longer required to report. So you had to decline the number of people reporting around 2011, 2012. And as I'm going to mention in the next slide, that can make it hard to determine trends, what's going on, because you change the number of people who have to report, which is kind of frustrating for hydrologists. But anyway, just want to highlight that evaluating total water use in the state and any trends is very challenging for a number of reasons. It's generally thought that the amount of water is underreported in the state. How much? I'm not sure who has a good handle on that or grasp on that. 10%, 20% more, I don't know. Remember, you have that 3 MGN requirement. There could be a bunch of users under that. Is there an cumulative effect there that we're missing? I wish I had an answer to that question. Unfortunately, I don't right now. Okay. And then the data we're looking at is only as good as what's reported to us. So sometimes there's errors. A lot of these are obvious errors, and DHEC will go back to the user and say, hey, can you double check these numbers and get it fixed? So I think they find most of them, but undoubtedly there's some errors in the reported use nonetheless that remain. And then, of course, I already mentioned changes in water use reporting requirements. And then we're talking about looking back to 2002, and we're thinking about trends. Well, we've had 3 significant multi-year droughts in that time period. Of course, for irrigation, that means water use is jumping up and down, depending on if you have a wet, dry, or normal year. And so we're trying to pick out trends out of, on top of a climate signal. It can be difficult as well. Very important to highlight, these results are still provisional. Like I said in the previous presentation, subject to change as DHEC makes any additional updates or corrections to the database. I don't expect any changes to be significant, however. I think we're consistently getting at least your larger users, which allows us to get a consistent picture of water use in the state, I think. I don't know if y'all may already know this, but we're looking at total agricultural withdrawals, whether it's ground or surface. Surface water makes about 1/3 of that total. It varies from year to year, but typically it's running between 30 and 35%. Okay. And then I was meant to add another bullet, but I forgot. And I think I've seen this in some news articles recently. The claim that only 2 to 3% of the surface water withdrawals are actually irrigation. And that is true statewide when you're considering irrigation, golf course, water utilities, and industry. Now, those 4 categories, surface water irrigation only makes up about 2 to 3%, and that again varies from year to year. As you're going to see in a couple of later slides, though, if a lot of that use is concentrated in certain basins. If you had that 3% distributed throughout the whole state, this wouldn't be a big deal at all. But the problem is a lot of that surface water use is concentrated in certain basins like the Yellowstone. Okay, here I just wanted to show, this is based on statewide total ag withdrawals on a monthly basis. I did it for years 2002, 2003, and 2012 and 2013, just to see differences between a wet and dry year, which is, you already know that. If you remember, 2002 was a dry to record Joe was talking about. 2003, if you remember, was a fairly wet year statewide, and then 2012 was a, maybe not the dry to record, but a pretty significant dry period. And the 2013, if you remember, was really, really wet. That summer was the wettest summer on record, so you can see the differences in them. You can see there's less difference maybe here in that 2002, 2003 year. Of course, we all know that the irrigation is done in the summer months, if you know, it just shows that as well. The next several slides, what I'm going to do is I'm going to show you, I'm going to do this by county and by basin, and I'm also going to focus on the Yellowstone and Salcahatchee. I'm going to show you reported water use for July 2012. Okay, I chose 2012 because it was a dry year. I chose July because that's when you typically going to have most irrigation. So I'm trying to find the maximum withdrawals you'd be seeing, okay, in a dry year. It does no good to do 2013 because most people weren't irrigating as much. So you don't get a picture of how much people can actually take out or taken out in the dry period. Let's see. Okay, so I'm going to start with, this is a map showing all the counties in the state. The black dots are reported surface water withdrawal. And then what I've done is I've set up bins for each county where I've summed up the total withdrawals for that month and year, July 2012, and then just color coded it. Your darker oranges and reds mean more water use, and then your yellows are less water use. Just point out I have a -1 to 0 here. Some counties actually didn't report any didn't report any water use at all. So that's a -1. If it's a 0, it means somebody actually reported the value, but it was a value of 0. But I just kind of lumped them together. Okay, so not every county actually has a surface water withdrawal right now. Okay, and then of course there are some that reported they didn't use the water, actually reported the value of 0. Okay, you can see that from this map that there's hot spots. Obviously, the upper Edisto region, parts of actually the whole Edisto basins are here. And then the headwaters of the Salcahatchee and Coosa are pretty heavy as well. You can see not much going on in the Piedmont, which isn't a surprise, maybe to some people. You can definitely see the hot spots are here. You can even see parts of the PD as well. Okay, and I think, I can't believe I forgot it. I think it was either Saluda or Orangeburg had the highest at 478 million gallons. This is million gallons per month, by the way. I can't believe I forgot which one was the highest. I think it may have been the Saluda Basin, okay, or the Saluda County. Now I'm going to go to the same map, except now I'm not looking at reported water use. I'm looking at current registered maximum monthly allowable withdrawals. Okay, and this has been a source of confusion. So let me make sure I'm clear on this. Each one of these green dots is a current registration. This is as of a database I got from DHEC from last November, I believe. So there could be a few more added since then. Okay. But what I've done is, say, take Coney County. Looks like there's 3 registered folks here, and each one has a registered withdrawal amount that's assigned to the registration. So I just sum those 3 up, and I get a number. Okay. So I do that for every county. All right. Now that number for each registered registration here is the maximum amount they're allowed to take in any one month. Okay. And we had a conversation about this earlier. How is that number determined? How does DHEC determine what that maximum allowable amount is for a given registration? And my understanding is that DHEC will ask the farmer or whoever runs the intake, how much water are you using? And sometimes they'll just say, well, our pump capacity is this, and that's what DHEC will use. If they don't provide any feedback to DHEC, what DHEC does is they go back, if they look to see if that user has any reported water use in the database. And if they do, they'll go find the maximum month, or the month that had the most amount of water withdrawn in their reported history. And that will become their withdrawal, registered withdrawal amount. Okay? Does that make sense how they do that? So what that means, though, is you could have some users who are not using anywhere near the amount of water they were using 10 years ago. For whatever reason, there was one month where they had to use a whole bunch of water. But on average, they always use a lot less. But because the registered amount is based on that maximum value, that's what DHEC chooses. And so that can skew some of these numbers on the high side. Okay, so that's like Greenville County. They're not usually they're in this high band here, but they're if you look at I looked at the last couple of years, they're not using anywhere near 100 MGM right now. Okay, at some point in the past, there was a month where they used a lot more water, so it's a tendency to kick those numbers up for a registered amount. Okay, Same, so you see, obviously, you have a lot more red and dark orange throughout the state. Of course, you see a lot of it sitting on the Edgestoke Basin, again, as well. So you see a lot of the hot spots still the Edgestoke, but you see a couple more counties cropping up, and the PD, a few more crop up. Of course, you had Greenville pop up. Again, it doesn't mean that these counties are using all that water. It doesn't mean they're using all that water, but that's how much they were allowed to under their current vegetation. If all of them use their maximum amount, that's what they could use right now. Of course, according to our current bill, farmer can come in with new registrations, and of course, as long as they fall from the safe yield, then they'll get a registered amount as well, and those numbers will go up. But just any questions on that? Just want to make sure that I was clear on that, because I think there's a source of confusion for some people.
So just according to that map in Aiken County, it looks like there's, what, 3, 4, maybe 4 wells that are registered, 4 withdrawals that are registered in Aiken County, and they're taking a lot of water. Is that kind of what you gather if you just look at that?
Peach Farm.
Peaches.
The peach farms up here that's where a lot of the water for the Edgestoke Basin is coming from, the peach farms.
That's what I was going to ask, if that was coming out of the Edgestoke.
Yeah, that's Walther's farm right there.
Right.
They didn't have a reported water use in 2012 because they weren't irrigating yet. So,
and who's over at the other side?
I'd have to go back and look at the database to see who that is. Not sure.
A bunch of sod fields.
Okay, thank you.
So,
That's interesting.
now I'm going to do the same thing I just did. So I'm going to do it by basin instead of by county, which is probably more informative for me as a hydrologist anyway. I've taken the same 8 planning basins that we're doing the surface water modeling for. And, these are, you have the Savannah, you have the PB, Taba, Broad, Saluda. This is the Edgestoke, Suckahatchee, and then Santee right here. Again, I just looked at July 2012 reported water use and just summed it up by basin. Okay, you can see Edgestoke Basin is by far the largest one. Okay, you can see Salcahatchee is pretty substantial. So is the PD, except the PD covers a large basin, so it's a larger number, but it's also more widely distributed over the basin. You can see like Savannah, Broad, Catawba don't use much. Saluda's in the middle somewhere, and Santee uses some, but not real high. Okay, so again, you can see the Edgestoke Basin is for whatever reason, I'm not sure why, it's a place where people like to use surface water for irrigation. So again, going back to that 3% number, yeah, it's only 3% of the total surface water use in the state, but as you can see, it's heavily focused in some basins. Okay, so that's good to point out. All right, so then I go to this next slide, actually all I did was add 2013 in red underneath. I don't know if y'all can read the one for right there, but I think it was 0. Just to show you, how much it can vary from wet to dry year. You still had 750 MGM for Edgestoke in 2013, but you see most of them go down, and some of them pretty significant at Salcahatchee. Okay.
What's amazing about the Edgestoke is you got the low flow versus other basins to begin with, right?
What's that?
The Edgestoke River versus the other basins, you got such a lower flow to begin with, it seems like to me, with a higher intake. So.
Well, it really depends on which tributary you're on, or if you're on the main stem or what, so it just depends on exactly where you're at in the basin to make that comparison.
Do you remember what the average flow of the main stem is?
Where at?
Gibbons.
Givans is, I didn't go down that far. For South Fork Edgestoke, there's a gauge at Denmark, near Denmark, that's running, I think, if I'm not mistaken, 720 CFS on average. At Walther's Farms, it's about 360, I think, 360 to 370 CFS. Okay, and actually, I'll go back to that.
And the Savannah, you're looking at 4,000 or something.
Yeah.
Just to give you.
Yeah.
I know it's speculation, but why do you figure there's not much on the Savannah? Is it harder to withdraw up Savannah? To get a permit or whatever?
You know, I don't know if they would have any requirements. I don't know if it would have anything to do with the water quality issues down
Like
there.
sharing the
You
river.
have to go through the core.
Groundwater is also a big user, I mean, groundwater is also a big source, so obviously. So,
No, there's a broad floodplain.
yeah, and I know that there's a floodplain
There's a
pretty
lot of
substantial
just-
down here, so I don't know, like, how much that is farmable. You know, All right, then oops, I'm sorry, I jumped ahead. Now, this is, again, looking at the current registered maximum monthly allowable withdrawal. It's a mouthful. You can see the numbers go up significantly, okay? And again, it doesn't mean the basin's using that. It's just that under current registrations, that's the amount total they could use, okay? Again, you see the Edstone is fairly large. And I think that does include the Walters Farm number in there as well. Okay. And then, last I want to just focus on the Edstone Stockahatchee, because that's what all the fuss is about, right? It's like you get sick hearing about it too, right?
Yeah, man.
So, yeah. What I did was I broke the Edisto and the Stockahatchee down into subbasins, the Coos and the Stockahatchee, South Fork, North Fork, Fort Hole Swamp, and then the rest of the Edisto here. And again, this is just based on reported water use. And I've actually added in the cubic feet per second number here, converted it over. So you can see, in July, during a dry year, they're taking an average of 41 CFS out of the river. So you can compare that to the Walters Farm gauge. I think runs about I think it's 370 CFS. So you're taking, I don't know what that works out to, but that's, if you look at an average flow, you're taking out, yeah. And then if you're having to get a lower flow, I mean, the river at that point can get down to 100 or less. I mean, it doesn't happen all the time, but during low flow periods, it can get low. You start getting where you could be taking a good chunk of that still out. And I think that's what people are concerned about.
And that wasn't a drought year, right?
This was a drought year. And of course, that means the river's low, but that's
Right.
also when the farmer needs it, so it's kind of like, what do you do? Yeah. Anything else I want to say about that? Any questions on this slide? And then the last one's just showing, I think, the AGCO, the current monthly maximum withdrawals, like I've shown for the other, for the whole state and counties as well. You can get to see the South Fork has a large, it can take up 85.
So, just a question about stream water. Would it be false to say that when you look at the really low flows in the summer, that's getting close to your base flow that's coming from the aquifers, and the rest of it is just that sort of hill slope, short-term storage and flow back into the stream? Is that?
I think so. Yeah, when you're in the summer months, when you not have a lot of rain, and the flow you're seeing is base flow.
So that's mostly from the aquifers. The rest of it is just, yeah. Okay.
I think that's all I had. There's a lot more about the data I could have presented, but I just only had 10 minutes, so this is all I did for this. Anyway, if you have any further questions, I just have some contact information up there. If you want.
I've got a question. How does DHEC determine the I mean, I know you said something about historical data or what they've used in the past, but is there a number that DHEC said, well, okay, we can permit this much on this river, and that's it?
Yeah, in the bill, there's something called the safe yield, which tells you how much water you can assign to a registration or a permit in a particular river basin. Okay. It's very poor criteria, one hydrologist, but there is a rule they abide by.
And that's defined as 80% of the average flow. The historic average flow, 80% of that is considered a safe yield that's available for withdrawal.
80%?
80% of the average flow. It's a huge number.
In the court, in that 80% of the mean daily flow is there less than 50% of the time when you look at it all.
Yeah, because the comments that I've heard is that, because of the complaining about the farm in Aiken County, is that they said, okay, we'll give this much water back, out of our permit. Well, that just gave somebody else the option to use that water,
That's right.
you know.
That's right.
Further
I
downstream.
had a DHEC official scratching his head over that too. So why did they just let them? Because he didn't think they'd even be using as much water as they wanted. Like, there's no way they were going to use that much.
Right.
So you just gave that water back for someone else to claim.
But if they do get permitted for that large amount, then nobody else could use that
That's
water.
it,
You know,
yes.
it takes it off
Right.
water or something, you know.
And I pointed that out to somebody, and they were like, well, you don't know, but they won't use that much in the future, and I'm like, well, they won't have any topsoil if they do.
I think what they're saying is, if they would just listen to Walker, let them keep that number they're not using, you wouldn't have to worry about that water coming out of the river. Yeah,
I've heard that before, I've heard that said. you know.
And of course, they went to groundwater, which
Mhm.
Which is
May
gonna
have some
affect
effect on
the,
It's gonna have some effect on the base flow, maybe, we don't know, it might not be a large number, but
how deep are their wells?
I think they're 500 feet.
500 feet?
But they're screened from, the screen where the water comes in from 250 to 500, more or less. So they're getting water from that Crouch branch and that McQueen branch, the two well branches.
And the rate, I'm sorry.
I was just going back to your map where it had at the surface, some of the layers were eroded away.
Mhm.
Where's Edisto in that, on that map?
Okay.
Does it still have all the layers, or has the upper three runs eroded down, or?
Yeah, when the river cuts through those layers, you know, obviously if one of those layers, the top layer is going to erode, it's just cutting down into the second layer and the third layer. I don't know if that's what you're asking.
I am. So
But,
where's the Edisto in that?
The Edisto? It's cutting down into the Gordon.
Okay.
Which is the second aquifer for
Right.
sure.
Okay.
And may even be down cutting into that third aquifer called the Crouch Branch. You know, that's something we're gonna have to look at tomorrow.
So it'll be interesting to see, because that kind of implies that the groundwater withdrawal will actually affect the surface water as well.
I believe it will, but
Okay.
that's
That'll be interesting.
hopefully we're gonna see that from the model, be able to
Okay.
determine that. And hopefully it will quantify,
Right.
how much of the base flow are you losing from the
So
public?
will you guys, and I know
Very
you're
interesting, I'm
early, I know you're
excited.
early, but will you guys be able to look at, a neighboring, or someone who's coming in? And
Yeah,
they're applying, they're gonna say, okay, we're gonna come in and.
absolutely.
So you
That's
guys-
a good reason.
Cause I know we got another large,
farm.
I mean, I just saw 40 log trucks yesterday, good, moving out.
Right down the road.
Yeah, one of the,
Across the street.
1,400.
that's a good way to use it.
Right
Yeah,
down the road.
the model that we use for that, if
Never.
it's coming in, it would say, okay, I need so many millions of gallons per day. Can you run that through the model and tell me,
Wow.
first of all, what the water level declines are gonna be in the aquifer? How much base flow am I gonna disrupt or, so you'll be able to tell that to them. Yeah, and then maybe you say, hey, maybe you should put your farm over here, or maybe you should look over here. There might be a way to help people cite their farm.
Yeah, Josh, I don't know if Joe said this, but this model is gonna be available to the public, for those of you smart guys to do that kind of thing.
You got a smart guy in here?
It's got the
Smart
numbers-
ladies.
The numbers you were just showing them, the million gallons a month numbers, that included more than just production farms, right? I mean, you said it was also golf courses and everything?
the numbers I showed you on the actual maps were all irrigation, agricultural.
Agriculture irrigation. Do you know what kind of percentage of, say, agriculture is based on? I would think golf courses have a pretty big impact.
Yeah, give me a second, I actually anticipated some of those questions, I just gotta find the right number to take. Alright. You wanna know how much golf course?
I'm just saying, I would think golf courses in general in our state are gonna take out more water than we've got a G in golf course.
Mm-hmm. It's a good question. Waiting for the answer.
Well, it's comparable, really, irrigation, on a statewide basis.
So we're using just as much water to grow grass as we are to grow crops.
I thought, well.
That you grow the grass just to cut.
Yeah.
I think if you took the city system and took the irrigation sector out of it, and what's actually used for consumption versus irrigation, you'd
Yeah.
see.
I mean, domestic
Yeah,
use.
domestic use,
You can
and
cut-
very high
You
percentage
know,
goes to
you
irrigation.
can kind of get at that number if you just look at the water use during the winter months and compare it to the water use per capita use during the summer months. You can see that difference.
Scott, how many other registered withdrawals are there that are not agriculture? I mean, what are the numbers? That was the question.
Registrations, I don't,
Do you
anything
know
else have to?
Like industrial, total withdrawal.
Right.
industrial registrations versus
Oh, you
agricultural
mean
registrations
permits.
and withdrawals?
You mean permits?
Yeah.
Maybe permits, but also in terms of quantity of water.
Kimberly Clark,
Well,
ton of it.
I don't know
And
exact
process
number.
amount.
You know, if they're using.
Is that data
water,
available?
It is available.
Yeah,
The number 1900 something is there. So-
Yeah, I have, the permit data.
Surface
I just
water.
haven't looked at that as closely as I have the registration.
I imagine with the Edisto that
Isn't
It's
the
not an
model
industry.
gonna, it's got those, when CDM Smith, when in Saluda, they went
Okay.
through the model, and the withdrawers are on there.
That's right.
It
By,
did
by
have that,
industry, by
okay.
agriculture.
I remember it did have that. Okay.
Yeah, I was just kinda wondering, as a pie chart, is agriculture half or a third
Uh,
of all withdrawals?
you mean for ground and surface or just surface?
Yeah, well,
Well, for surface, that's what that 3% number I was saying. On a statewide basis, surface water withdrawals for agriculture irrigation makes up only 3% of the total public water supply, industry, golf course, and irrigation. It's a small percentage.
so it's very small.
But then it's concentrated.
Yeah, but that's the thing, is if statewide, if you,
Yeah,
but it's, but Edisto probably has a much higher, the percentage is much higher in Edisto than Salcatchee does.
You know what complicates
Which I
things too?
should do that calculation at some point. but I haven't
This
done
is
it.
the reported use. For agriculture, we consider that to be 100% consumptive. All of it gets used, none gets returned to the river.
Right.
So with municipalities, 50–60% can be returned to the river, same with industries and thermal electric, probably less. But
Okay.
that's another.
That's another consideration. I didn't think about that.
Will these models be used for DHEC purposes? I mean, for their permitting?
Yeah, the groundwater model to evaluate these groundwater
Right.
permits and surface water models to evaluate the surface water permit application.
Like, in saying that, will you look out 50 years and say, well, wait a minute, we can't permit that much, 45 years
I don't
ago?
No,
think DHEC
no, they're not gonna do
So
that.
we'll wanna do that, we'll wanna look at that,
Yeah, right.
to anticipate potential conflicts, but I don't think that's a good question. I'm pretty sure DHEC's just gonna base it on current conditions. It's a good thought, but bring it up to DHEC.
Thank y'all very much for the presentation.